Welcome to my YouTube channel. So here today we are going to be looking at the 2023 paper. So under this paper we are going to solve all these questions. So the full paper we are going to solve it. So this is very good if you are looking at A level, basically anywhere at any university or anywhere in the world. This is a really good review. So all these questions will be solved. Now let us begin. The first question is a partial fraction question. So it says that we have 2x plus 1. So if we have such type of equation, 2x plus 1 over x to the power 3 minus 1. So how are we going to solve this one? So it's very, very easy. So what we are going to do is that we are going to let's first deal with this. So make sure that the bottom part is factorized if it can be factorized. So factorizing this by looking at it, if you have x cubed minus 1, the number that you can put here to give you 0 is, if you get 1, it will be 1 to the power 3 minus 1, which is equal to 0. So that means to say x is equal to 1 is a factor. So if it is a factor, you are going to use it. So when you use the factor, you are going to be like, if x is equal to 1, you can bring it back here. So it will be x minus 1 is equal to 0 like that. Then what you are going to do is you are going to divide. So you are going to get your x minus 1. Then you have something like this. Then you are going to put your value here, which is your x to the power 3 minus the 1 like that. So you are dividing it. So this x to the power 3, x to the power 3, we also have this x, let them divide. So it will be, in fact, we are supposed to make it, you are supposed to make sure that it is decreasing in ascending power. So this will be 0x squared plus 0x. Then we have, we have minus like that. So then this x cubed, you are going to say x cubed divided by x will give you x squared. So you are dividing this and this. So you are going to write your x squared here. After you write, multiply. So this will be x squared times x. It will be x squared times x is x cubed. X squared times negative 1, it will be negative x squared. Then you are going to subtract like that. So this will be x cubed minus the x cubed that is here. So if you are subtracting the same number, it will be 0 like that. Then this 0 minus negative. So this is the same as negative times negative. It will be positive x to the squared like that. Then what you are going to do is that you are going to divide again. So this x squared, let it divide your value that is here. Let it divide the value that is there. So this is the same as having x squared divided by this x. It will cancel. You are going to remain with 1x. So you are going to write your plus x like that. Then after that, multiply. So it will be x by x. It will be your x squared. X times negative 1, it will be negative x. Drop this 0. So you have 0x like that. Then you are going to subtract. So this is the same as, if you want, you can do this negative. So that you have your x squared minus x. So if you are dividing x squared minus this x squared, it will be 0. So you are going to have your 0 like that. You can just write 0. Negative by negative is positive x, because this is 0 minus minus. So negative by negative is x like that. Then from there you are going to drop this one. So it will be negative 1. Then divide. Your x divided by x is equal to positive 1. So if you divide your x divided by x, it will give you positive 1. So this is what we have. So the only thing we are interested in is the top part. When we are doing this, the top part and this and this. So we are going to say that our x minus 1, our x cubed minus 1 is equal to, you get this. So it will be x minus 1 times our x to the power 2, you are writing this, plus our x, so you multiply them, plus our 1. If at all this one can be factorized further, you can factorize it. If it can't, then you have to use other means. So this means that the number on top was 2x plus 1, so you're going to say your 2x plus 1 over the x minus 1 and your x squared plus your x plus your 1. So this is what you have. So now you equate it to your a becomes over the x minus 1. Now I've done the complete video for partial fractions. So as you can see, this is x minus 1. It is a straight line equation. So if you have a straight line equation, on top you should have a constant, which is a. A can represent any number. A can be 5, a can be 6. So in short, if a number such as 6 is on top, down here we should just have x to the power 1 like that. So now this is important to help you remember that if this one you cannot factorize it. So even if you try to find the product sum and factor, you can't factorize it. Therefore, you will say plus. Then this one, since it's a quadratic which you have not factorized, you are going to say that it will, on top, you are going to have bx plus c. Why this? This is a linear equation. This is a quadratic. Power 2, the one on top, power 1. Even here, power 1, the one on top is power 0. Like that. So over, we have our x squared plus our x plus our 1 like that. So this is basically what we have. So after doing that, we are going to multiply. So let me just reduce the font size of this. So we are going to reduce the size of this. So we are going to have something like this. So what you're going to multiply is the denominator, which will be your x minus 1, then your x squared plus your x plus your 1, like that. So then this multiplied by this. So as you can see, this is the denominator, this is the numerator. So automatically, if this and the one that is down there are the same, they are going to cancel them. So this is what we have. So this and this will cancel each other like that. But so we are going to have our 2x plus 1. But remember, this number is multiplying everything. So on the second part, this multiplied by this one and this one will cancel each other. So we have our a, open brackets, we are remaining with our x squared plus our x plus our 1. Likewise, when we have our final part, this multiplied by this one and this one will cancel each other. Then we have plus our bx plus our c, then multiplied by our x squared plus our x plus our 1. So this is what we have. Therefore, from here, why do we have the same thing here? No, this one has been cancelled here. So this and this have been cancelled. So we are remaining with this. So we were supposed to write this. So we say our x minus 1 like that. Then we have what we are going to do is that let's first eliminate b and c because they are attached to each other, or rather connected. So what we are going to say is that let your x be equal to positive 1. So that when you have your 1 here, your 1 minus 1, it is going to give you 0. So replacing it there, it will be 2. 1 plus 1 should be equal to a. We have 1 squared plus 1 plus 1. So we are just replacing. Then we have plus our b, where there is x, we put 1, plus our c. Then we have 1 minus 1 like that. So this gives us 2 times 1, it is 2, plus 1 should be equal to a. 1 squared is 1, plus 1, that's 3, like that. Plus we have our b, plus b times 1 is b, plus our c there. 1 minus 1 is 0. So this gives us 2 plus 1, that would be 3, should be equal to 3 times a, it is equal to 3a, like that. 0 multiplied by everything is just 0, so we forget about that. So we are going to get when we divide our 3 here, we are going to get our a is equal to positive 1, like that. So we get our positive 1. From there, we are going to get our other value. So looking at this equation here, the other letter that we can eliminate is b, because b is connected with x, by making x equal to 0. So let's get this equation. So when x is equal to 0, we are going to have our 2, where there is x, we have 0 plus 1 should be equal to a. Then we have our 0 squared plus our 0 plus our 1, like that. Then we have plus our b, where there is x, we put 0 plus our c. Then we have 0 minus 1. So this gives us 2 times 0 is 0 plus 1. So we are just going to have 1 is equal to our a. 0 squared is 0 plus 1, that will be 1. Then we have plus our b times 0 is 0, so we don't write b. So we have 0 times, or we have c times our 0 minus 1, it's a negative 1. So we are going to have 1 should be equal to a minus c. Why minus c? Simply because negative by this positive is negative. It's negative 1c, but we don't write the 1. So this is what we have. Now that makes it, we know that a is equal to positive 1. So therefore, we can be able to say 1 is equal to, where there is a, we put 1 minus c. So the 1 will go this side. So we have 1 minus 1 is equal to negative c. So this gives us 1 minus 1 is 0, should be equal to negative c. We divide by negative 1, our c should be equal to 0, like that. Getting the equation again to find our final value, which is our b. Now there is no way for you to eliminate any letter without eliminating b. So therefore, what we are going to do is that we are going to expand it and compare. So we are going to have our 2x plus 1 should be equal to a times x squared. It will be ax squared plus a times x. It will be ax. Then we have our a times 1. We have plus our a. Then how you expand this, you let this multiply everything that is in the second bracket, so that we have our bx, open brackets, x minus 1. Then we have our c multiplies everything there, so we have plus our c, open brackets, x minus 1. So this is the simple way of representing. So we have our 2x plus 1 should be equal to, we have our ax squared plus our ax. Then we have plus our a. Then we have plus bx times x. So bx times x is going to give us our bx squared. Then bx times negative 1, it's going to give us negative bx. Then we have our c times x, it's going to give us cx. Then we have finally our c times negative 1, it's going to give us negative c. So from here, what we can just do is compare. Get any of them that have got b. So you have your ax squared and bx squared. You can equate it to any number here that has got x squared. So this side it's there, but it's 0x squared. So with that said, it simply means to say so this gives us 1 over x minus 1. Then we have our negative by x, it will be negative x over x squared plus our x plus 1, like that. So this is the answer. So our 2x plus 1 over x cubed minus 1 is equal to that as a partial fraction decomposition. Let's go to our next one. The next question says, find the center and length of the radius of the given circle and graph it. So we have the equation of the circle, x squared plus our y squared minus our 10x is equal to 0. So how are we going to answer this? So to answer this one, what we are going to simply say is comparing with the general equation. So comparing with the general equation, we are going to have something like this. So we have our x squared plus y squared minus 10x. So our general equation is x squared plus y squared plus our 2gx plus our 2fy plus our c should be equal to 0. You should know this equation. So we are comparing. Make sure that the coefficient here is 1 so that they are balancing like this. So we have something like this. So we are going to equate. So that means to say this one with x will be equal to this one. So this is what we are going to do. So we have our 2gx. It should be equal to negative 10x like that. Then we divide by x. We divide by x so that we have our 2g should be equal to negative 10. We divide by 2. We divide by 2. We are going to get our value, which will be equal to g should be equal to negative 5 like that. You are going to do the same for 2fy. Now you are going to get this 2fy. Look at here. Do we have any number with y? So it's there, but it's 0 y. So we are going to compare our 2fy to be equal to 0. We divide by 2y. We divide by 2y. That means that our f is equal to 0. 0 divided by 2y is 0. So in fact this is still 0y. So this and this cancels. 2 divided by 0 is 0. So that means to say the center, what are we asked? We are asked to find the center. So the center is given by negative g, comma, the negative f. So in this case it will be, the center will be equal to negative, then g is negative 5, comma, 0 is 0, whether negative or positive. So this is what we have. So our center will be equal to positive 5, negative by negative is positive 5, comma, 0 like that. So this is what we have for the center. Now we are required to also find the radius. So to find the radius, we are going to say the radius r is equal to the square root of our g squared plus our f squared minus c. So we have the radius should be equal to, what is our g value? G is equal to, we have 5. So we are going to say 5 squared plus, what is our f? Our f is 0. We found 0 minus our c. Our c is also 0. As long as it's not showing, c is a constant. At least if we had plus 5, that means that's the value of c. So that means to say, if you have your plus 5 this side, it means to say you have to take it there. We just don't get it direct. So I've done these topics in separate videos. So we have our r should be equal to the square root of 0 squared plus minus 0. 5 squared is 25. So we have our r should be equal to the square root of 25 is 5 like that. So this is what we have for r. So our center is equivalent to 5, 0. Our r is equal to 5. So to finally sketch according to what they have asked for, we are going to do this. Looking at the center is at 5. So sketching is very easy. Sketching a circle like this is very easy. So we have the center is 5, 0. So that means x is 5 and y 0. So we have a 5 is here. Then what we are going to do is that, look at radius is 5. That means to say from the center to the circumference, you are going to move 5 units up, 5 units this side, 5 units this side. So 5 units this side falls here. 5 units upwards will be from here, it's 0. Then we are going to have our y value will be 5 at this point. You are going to go down 5 units, so it will be negative 5, so which will be here, and 5 units this side, which will be a 10 like that. Then from there you are going to draw your circle, connect the points. So you are going to have something like this. So this is what we have as our circle. Just connect the points like that. So this is our circle as required. Let's move on to our next question. So prove the result by induction. So 1 times 3, 2 times 4, 4 plus that value. So how are you going to prove this one? So the first thing that you are supposed to do is you're going to begin with your basis or basic step. So the basic step, you're going to just let your n value be equal to 1 or any other value that you want, but 1 is very easy to test. But before that, let's write this down. So we have our 1 times 3 plus our 2 times 4 plus our dots. We have so we have plus there, we have plus dots plus our n, open brackets, n plus 2 should be equal to, we have 1 over 6 n, open brackets, n plus 1. So this is what we have. So we are going to test. If n is equal to 1, that means to say we should expect the answer to come from here. So I've already done the induction topic, the full topic. So we are going to replace there. We have 1 over 6 times, where there is n, we are going to put 1. So we have 1 like that, open brackets. We are replacing here. We have 1 plus 1, then we have our 2, open brackets, 1 plus our 7 like that. So this gives us 1 over 6. We have times this one, won't change anything, so let's forget about it. 1 plus 1 is 2. Then we have our 2 plus our 7. So we are going to have 1 over 6 like that, times our 2 times 2 plus 7 is 9 like that. So this is going to give us something like this and this. We are going to have 3 here, 1 there. So we have our 9 on top over our 3. 9 divided by 3 is 3. As you can see, 1 times 3 is equal to 1 times 3 is equal to 3 as well. So that means to say it is true. Then the second thing that you are supposed to do is you are going to come up with your inductive hypothesis. Hypothesis is guessing. So here it's more like you're making an educated guess. If it's working on top, it means to say even here it will work. In another video, I just made a small mistake where just the naming. So the next step is the inductive hypothesis. So under the inductive hypothesis, you are going to assume that it is true for n is equal to k. If that's the case, we are going to say we are letting our n be equal to k. So we are going to have our 1 times our 3 plus our 2 times 4 plus our dots plus our, where there is n, we are going to put our k. Then we have our k plus 2 like that, should be equal to 1 over 6 times we have our k like that. Then we have our k plus 1. Then we have our 2k plus our 7 like that. So after doing that, so we are assuming that it is true. So we go now to the inductive step. So we say inductive step. So in the other video, it was just a slight mistake where there was just an interchange of these two, but everything was very much alright. So we are going to show that it is true for n is equal to k plus 1. So now how we are going to do this is by adding this same k plus 1. We are not going to substitute, but we are going to add. So therefore this means to say we are going to have the same exact equation. So this same equation that we have here, but we are just going to, so this same equation, then what we are going to do is that the next step is we are going to add this. Now remember, we are adding, so we have the next term like that. So we are adding this k plus 1. Now we just don't add k plus 1, we are substituting. So in the equation of this, so whatever you have here is where you substitute. So we have our n plus our n, open brackets, we have our n plus 2 like that. So this is where now you substitute. So you substitute this. Where there is n, you are going to put your k plus 1. So we have our k plus 1. It's only that space. Let's move this. So we have our k plus 1 I've substituted here. Then also we have our k here, k plus 1. Okay, spaces. Okay, so let me do this. Let me cut this. So we have our k plus 1, which is substituted here. Then we have our k plus 1. Then we have plus our 2 like that. So this is what we have. So this should be equal to the terms that are, or I can even write it here. So this is equal to, but take note that it's written there. It's on the space. So this should be equal to what we had here. What we had here. Then whatever we had, we now add the next term. So the next term is us replacing, for n we put k plus 1, for this we put k plus 1. So this will be our k plus 1. So in short, we are just adding this same term. So we have our k plus 1 like that. Then we have our k 1 plus 2 is 3. So we have k plus our 3 like that. So this is how we add. From here, you just do the math now. Okay, so we have, so what we are just going to do now is manipulate the equation. So what we have is, let me even have more space. So move 6 is the common denominator. So it is, the two equations are separated by this plus. So 6. So whatever is on top, since 6 divided by 6 is 1, it will return. So we have our k plus 1. Then we have our 2k plus our 7 like that. Then we have plus 6 times this one, it will be 6. Then we have our k plus 1. Then we have our k plus our 3 like that. So this is what we have like that. After doing that, we are going to pick out what's common. So this and this are common. So we are going to say our k, then we, our common is the k plus our 1 like that. So when we remove our k plus 1, then what will remain is this k and this number, which is our 2k plus our 7. Then we have plus our 6 like that. Then our 6, then what is in the bracket is our k plus our 3. So over, we have our 6 like that. So this gives us a value of k plus 1. Then in the brackets, we have our k times k. So we need to, unless if the brackets were the same, we could have just factorized. But in this case, we are forced to expand and factorize. So expanding this, we are going to get something like our 2k times k, it will be 2k plus 7. We have our 2k times k, it's 2k squared, plus our k times 7, it is 7k. Then we have our 6 times k, it is 6k, plus our 6 times 3, it's 18 like that. Then this over our 6. This over our 6. So this gives us our k plus 1 like that. Then we have our 2k squared like that. 2k squared. 7k plus 6k, it will give us 13k like that. Then we have plus our 18 like that. So this gives us over our 6. Then what we are going to do is factorize this. Okay, factorize this, but let me see if there's any easier way. of just finding it direct. Okay, looking at it, we just need to factorize. So factorizing this, we are going to have our 2k squared plus our 13k plus our 18. So factorizing this, we are going to get a value that will be equivalent to the product will be equal to our SC. So the product is 2 times 18, which will be 2 times our 18, which should be equal to, we have 36, like that. Then the sum is equal to B, which will be equal to 13. Then the factors will be equal to, what are the factors? Two numbers which when you add them they give you 13. When you multiply they give you 36. So those two numbers are our 9 and our 4, or we can put them as 4 and 9. It is still okay even if you interchange them. So where you see your 13k, you can put these two values. So if I multiply 9 by 4, it will give me 36. When I add, it's 13. So we are going to have our 2k squared plus, where there is 13, we are going to say 4k plus 9k. When you add these two, it's 13 plus our 18 should be equal to 0. So our common values are 2, so 2 can enter into 4, so we can say 2 and k are common. Then the remaining is k plus 4 divided by 2 is 2, like that, plus we have our 9 is common, so we say 9 open brackets k plus 18 divided by 9 is 2, should be equal to 0, like that. So here what is common is k plus 2, k plus 2, like that. So we are going to say our k plus our 2, like that, in one bracket. Then the other bracket will be our 2k plus our 9, like that. So this is what we have. So where we see this, we substitute that. So it becomes our k plus 1 is there. Then the one that is unfactorized, we are going to put our k plus 2. We have our 2k plus our 9, then over our 6, like this. So this is what we have. Now testing by substitution. So we are going to substitute n is equal to k plus 1 in that equation and see what it will give us. So the equation, which is from this equation, this value, we are going to substitute k plus 1, because at first we did not substitute, we added. If it gives us the same, then it is true by mathematical induction. So getting this equation, we are going to have, let us do that equation. So when we get this equation, substituting that value gives us, we have 1 over 6. Then we have our k plus 1. Where there is n, we put k plus 1. Where there is n, we put k plus 1. Then we have plus 1, like that. We have 2. Where there is n, we put k plus our 1 plus our 7. We are just replacing. So this gives us 1 over 6. We have our k plus 1. 1 plus 1 there. So we have k plus 1 plus 1 is 2. Then we have 2 times k, it will be 2k plus 2 times 1 is 2 plus our 7, like that. So this gives us 1 over 6, open brackets, k plus 1. Then we have our k plus 2. Then we finally have our 2k plus our 2 plus 7 is our 9, like that. So this is what we have, which can be written as, if you multiply throughout, this can still be written as, your common denominator is 6, so the 6 can even be written like this. So you can say that since adding k plus 1 and substituting gives the same result, then you can say it is true by mathematical by mathematical induction. So that is how you answer that one. You get your 5 marks. Let's move on to our next question. Our D says find the fourth term of the binomial expansion. So how do you find the term? So the term, just finding any specific term, is given by the term should be equal to A. We have n combination r, then we have a to the power n minus r, b to the power of r, where if you have the equation 2 minus your x over 2 to the power of 9, you identify. So this is your a, your b is equal to this is equal to b, so the whole of this is equal to b. So you are going to say r is equal to 3. Why is r equal to 3? Because for any binomial expansion, if you are looking at the fourth term, r is equal to 3. If you are looking at the first term r is equal to 0. Second term r is equal to 1. So r will be less than 1, like that. So getting that value, r is equal to 3, we are going to now substitute. So we have term number 4 should be equal to, we have our n, the n is 9, so n is the power, so we have 4. Let me just identify them. N is equal to 9, then we have our a is equal to 2, then our b is equal to negative x over 2, like that. So our 9 combination, our r is 3, then we have, what is our a? Our a is 2, so we say this is 9. So a is equal to 2, so we say 2 to the power of our 9 minus our r, which is our 3, like that. Then our b is negative x over 2 to the power of 3. So this gives us a value that is equivalent to term number 4 should be equal to, our 9 combination 3 gives us 9 factorial over, you subtract, we have your 9 minus your 3 factorial over then the 3 factorial, like that. So I've already made some videos explaining how you do this. So we have 2 times 9 minus 3 is 6, then you have times negative x to the power 3 is negative x to the power of 3. We have over, so the negative will return as long as you are looking at an odd power such as 3, 5, 7. As long as it's odd, the negative will return. Then we have our 2 to the power of 3, like that. So to make our work easier, so we are going to use the rules. So we have our 9 factorial over 9 minus 3 is 6, so we have 6 factorial, 3 factorial, then we have times our 2. So as you can see from the rules of indices, just take one base. So we are going to take 2, it's to the power 6. Then since this 2 is down here, subtract the powers. So we have times our negative x to the power of 3. So this gives us, we are going, 9 factorial means 9 times our 8 times our 7 times our 6 times 5. But instead of going times 5 times 4 until 1, you can end on 6, since 6 is down here. 6 factorial, because 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. So you are going to end here 6 factorial over 6 factorial times your 3 is 3 times 2 times 1. Then you have times 2 to the power of, what is 6 minus 3 is 3. Then we have times our negative x to the power of 3, like that. So we cancel this, we have our 9 times 8 times our 7 over 3 times 2 is 3 times 2 is 6, but we can just let it be like this. The aim is for us to avoid multiplying a lot so that we don't make a mistake. So one, we can forget one, like that. So we have our 2 to the power of 3, which is just 8. So we are going to say 8 times negative x to the power 3, like that. So this gives us our value, which will be equal to this can enter here 3 times, this can enter here 4 times. So we are going to have, our value will be 3 times 4 times 7 times 8 times our negative x to the power of 3. So multiplying, let's multiply these first. Let's multiply these. So first let's multiply the big one. So 7 times 8 will give us a value such as 56. So 7 times 8 is 56. So we are going to multiply 56 by our 4, which will give us 4 times 6 will give us 24. So 4 remainder 2. This times this is 20 plus 2, that's 22. So we have our 22. Now multiply times the 3. So times our 3, we are going to have our 12 remainder 1. We have 2 times 3 is 6 plus 1, that's 7. 3 times this is 6. So this is going to give us our 672 times our negative x to the power of 3. So multiplying this, we are going to have negative 672 x to the power of 3 like that. So this is the value that we have gotten. So this is our term number 4 like that. So that is how we find any specific term. Let's move on to our next question. Find, not this one, if xy is equal to 64, then we have the log of our y base x plus the log of x base y is equal to 5 over 2. Find x and y. So we are going to first deal with this. The log of x y plus the log of x base y should be equal to, we have our 5 over 2. So as you can see, we need to have the same letter, so we can convert this x to become y. So this becomes, we can let this log of our xy be equal to a, so that how we know how we deal with logs. This one comes there, it becomes the base, so y should be equal to x to the power of a like that. From here, what we are going to do is, our aim is to have y here, so we are going to introduce the log of y on both sides. So we have the log of base y, then we have this y should be equal to the log of y, then we have our x to the power of a like that. Log y base y is equal to, so log of the same base is equal to 1, so we say 1 should be equal to, we have this a comes down here, so we have our a log of our y base x, or base x base y. So we have over log x base y over the log of x base y like that. So this is what we have. So our a is equal to 1 over our log of x base y. So remember, a was the one that we equated to be log of x base of y. So changing a into this, that means we are going to have this. So you are now going to just substitute. So let's get this equation. So getting this equation, we are going to have something like this. We are going to have something like this. Our 1 over, where there is this, we are going to have 1 over the log of our y like that, plus our log of base x of y should be equal to, we have our 5 over our 2 like that. Now as you can see, they both have y, they both have y, they both have x, they both have x. You're just going to let your any value such as p be equal to the log of y x. If you want, you can multiply, but to avoid making a mistake from this stage, you can just equate like that. So that means to say it will be 1 over, where you see this, you are going to put p like that. Then we have plus, even here we have p should be equal to 5 over 2 like that. So this gives us our common denominator here is p. So we are going to say p like that. Then p divided by p is 1 times 1, that's 1, plus we have p divided by 1 is p times p, that's p squared. P squared should be equal to 5 over 2. So from here we cross multiply. So crossing multiply, this 2 multiplies everything on top, so we have 2 open brackets 1 plus p should be equal to 2 times p times 5, it will be 5p like that. So this gives us 2 times 1 is 2 plus 2 times p is 2p should be equal to 5p like that. So remember, there is a small mistake. We have p there, so we say p squared here. We have p squared, so this 2 multiplies everything there. So this is what we are going to have. Rearranging properly, this gives us our 2p squared plus our 2 should be equal to 5p. We are going to have our 2p squared, then we have minus our 5p when this comes this side, then we have plus our 2p should be equal to 0. So two numbers, we multiply them, so the product in this case is equal to AC, which will be equal to our A is our A, our B, our C. Our A is equal to 2 times our C, which is 2, which should be equal to 4. Then we have our sum should be equal to B, which should be equal to our B is equal to negative 5. Then our product, our factors, two numbers, we multiply them, they give us positive 4. We add them, they give us a negative 5. It's negative 4 and negative 1. So replacing these where 5 is, we are going to have our 2p squared minus our 4p minus p, like that. Then we have plus our, why am I having 2p there? It's just 2. These 2. So we have plus our 2 should be equal to 0. So 2p is common, so we say 2p open brackets. We have our p, 2 divided by 4 divided by 2 is 2, so we have minus 2 like that. Then we have minus 1 is common here, negative is common, so we have negative p divided by negative 1 is positive p, so we say p. Negative 2 minus divided by negative 1 is minus 2, like that, should be equal to 0. So our two brackets, we have p minus 2, we have our 2p minus 1 should be equal to 0, like that. So it's either p minus 2 is equal to 0 or our 2p minus 1 is equal to 0. So that means to say our p is equal to 2 or our 2p should be equal to positive 1 if 1 goes this side. Here 2 went that side. So we divide our 2, we divide our 2, our p should be equal to 1 over 2. Our p should be equal to positive 2, like that. So with that done, remember p was gotten from, we said p is equal to the log of y base x. If I recall correctly, the log of y base x is p. So we are going to say, we are going to replace where p is equal to this. So we have our 2 should be equal to the log of y, log of x base y. Remember, this will go the other side, it will become the denominator. So we have y, or should I say the base. So we have y to the power of 2 should be equal to x. So whatever is here, it just comes down there. So you can just think of it, it comes down there. Should be equal to that. Now, knowing the other equation that they gave us in the question is xy is equal to 64. So we are going to say our xy should be equal to 64. So you are solving them simultaneously. So since x is the one without the power, make y the subject of a formula, or make x the subject of a formula. So we have over y, whichever one you make, it's still the same answer. So we have x is equal to 64 over y. So where there is x, you replace this. So this gives us our y squared should be equal to, we have where there is x, we put 64 over y. So we are going to cross multiply y times y squared, it is y to the power of 3, should be equal to 1 times 64 is 64. Find the cube roots. Find the cube roots. Cube root of 64, one number, when you multiply it 4 times, it gives you 64 is 4. So our 4 times 4 times 4 is equivalent to 64. So the cube root of 64 is 4, like that. If you can say now, when y is equal to 4, you have made x the subject of a formula, and your x is equal to 64 over 4. Your x value will be equal to 64 over 4, which will be equal to 64 divided by 4. When you divide, it will give you 16. So you can just do 6 divided by 4 is 1, remainder 2, 24 divided by 4 is 6. So we have 16. The other one was this. So you do both. We are going to say when your p is equal to 1 over 2, for the equation is saying p is equal to the log of x base y. So you have half there, so you are going to say half should be equal to the log of x base y, like that. So this y goes this side, so we are going to have something like our y to the power half should be equal to, we have our x, like that. Then what we are going to do is that compare the two equations. Xy should be equal to our 64. So making x the subject of a formula, we are going to have x over this. So our x value will be equal to 64 over y. So replace wherever you see x, replace by 64 over 4. So you are going to get your y should be y to the power half should be equal to, we have our 64 over our y, like that. Then cross multiply. Now this one is not straightforward. So what we have is y to the power half times y, when we cross multiply, should be equal to 64 times 1 is 64, like that. Then we are going to say y to the power. So we have half plus 1, it will be half. So you pick one base, which is pick one base and add the power. So we have plus 1, like that, should be equal to 64. So we have y, then we have 2. 2 divided by 2 is 1 times 1 is 1, plus 2 divided by 1 is 2 times 2 is 2, should be equal to 64. So this gives us y to the power 1 plus 2 is 3 over our 2, should be equal to 64. So this gives us, so what you're going to do is that introduce the multiplicative inverse to this number. So 3 over 2, you introduce your 2 over 3, so that the top becomes the denominator, and that, so that they can cancel each other. Now whatever you do this side, do also on this other side. So we have 2 over 3. So this and this goes, this and this goes. So our y should be equal to, we have our 64 to the power of 2 over 3, like that. So find the cube root. So you have your cube root of your 64 to the power of our 2, like that. So the cube root of 64 is equal to, what do we have as our cube root of 64? So remember, it is 4 to the power of 2, like that. So our y should be equal to 16. So the values have interchanged. At first, y was the one that was equal to 4. Then here, y is the one that is equal to 16. Now remembering that our x is equal to 64 over y, we can replace our x is equal to 64 over, what is our y? Our y is 16. 64 divided by 16 is 4. So we can say that when x is equal to 4, y is equal to 16. And when x is equal to 16, that is for the first answer that we found, our y y is equal to 4, like that. So they have interchanged like that. So this is the required answer. Let's look at our next question. Question 2 says A is a point -1, 2, B is the point this, C is the point that. So our A is -1, 2, our B is our 2, 3, our C is our 3, 5, like that. Then what we are going to do is that find the coordinates of P. Now, provided that they have told you that P is a point which divides BC in the ratio of 3 to 4, that means to say you have something like this. This is your P, then this is your B, this is your C. So it divides this line in the ratio of 3 to 4. So this is what you have. So now remember, a formula for when a line divides a circle internally. So this is how they can ask you internally. We are going to be using this formula. So since P is the point, we are going to split it into Px. Px will be equal to, so the formula shall be, we are going to have the lambda x2 plus the mu x1 over, just add the lambda and the mu, the lambda plus the mu. Others use the formula for Px, it is equal to, you can use m x2 plus n x1 over the m plus n. Remember, just these two, lambda and these are just numbers. These are just numbers. So you can use any letters. So if your lecturer insists on using this, you can use it. Now, how do you use this equation? So you look at your points. So you have your BC. So let's get our BCs there. So getting our BCs there, we are going to have something like this. Your M and your N is the ratio of division, where M is the first division, which is your 3. Then your N will be your 4. So we are going to have, even here, so this will be your lambda will be your 3. Your mu will be your 4. So just the order. So you can use this, or if you are conversant with these letters, you can use these letters. So this gives us our Px should be equal to, what is our M? Our M, so remember this is our x1, y1. This is our x2, y2, like that. So our Px will be equal to, what's our M? Our M is equivalent to 3. So we have our 3. Then our x2 is 3, like that. Then we have plus, what is our N? Our N is 4, the other division, times our x1, which will be our 2, like that, over, we have our M plus N, so we are going to add the divisions. So we have 3 plus 4, like that. So this is our Px. So Px should be equal to, we have 3 times 3 is 9 plus 4 times 2 is 8 over 3 plus this is 7. So this gives us 9 plus 8 is 17 over 8. So this is our coordinate for x. Then the coordinate for y, it is still the same. The equation is the same, but you just interchange the y. So you are going to say m y2 plus n y1 over, we are going to say, over our m plus our n, where m and n are the divisions. So the first division is 3, our y2 is, so let's get the equation and put it here. So this is the equation. So our y2 is 5, so we have 5 plus our n, the second division is 4, y1 is 3 over our 3 plus our 4, like that. So this gives us 3 times 5 is 15. Then we have plus 4 times 3 is 12 over 3 plus 4 is 7, like that. So this gives us our value 15 plus 12 is 27 over our 7, like that. So this is our py. So the coordinates of p coordinates of P should be, we have found our x is 17 over 7, comma our y is 27 over 7, like that. So these are our coordinates of P as required. We get our 2.5 marks there. Then this one will require us to think a bit. So we have find the coordinates of Q. Now the instruction for Q, it says, and Q lies on the line AB. So it lies on the line AB. So we have A here, we have our B there. Then it divides so we have the Q here. Then we are told that AQ, from A to Q, it is 2. A to B is equal to 5. So if you put 5 here, it's wrong. Why is that? Because they are saying AB. So that means from here up to here, it's 5. So if it is 5 from there up to there, that means to say from here up to here is 3. So that 3 plus 2 gives you 5. So these are the divisions. Be careful. If you are given the ratio, you replace direct. But if you are given this, you have to think. So this is our value. So we are going to say QX is equivalent to, we are going to use the same formula since it's dividing the line like that. So we are going to have our M x2 plus n x1 over m plus n. Then we have replacing, this will be, so let's write our AB. Our AB has got coordinates such as -1, 2. Our B has got coordinates 2, 3, like that. So this gives us a value that will be equivalent to, so we have our QX should be equal to, what is our M? Our M, the first division is 2. So we said 2. Then our X2 is 2 plus our N is equal to 3. X1 is -1. Then over, we have our M, which is our 2 plus our 3, like that. So this gives us our QX should be equal to, we have 2 times 2 is 4 plus, or rather minus 3 times this is -3 over 2 times 2 plus 3, that's 5. So this gives us our QX should be equal to 4 minus 3 gives us 1 over our 5. Likewise, find your QY, which should be equal to, we are going to have the same thing, the M y2 plus your N y1 over the M plus N. So we have our M, which is equivalent to, what do we have as our M? Our M is equivalent to 2. Then the values of those others is our y2 is 3 plus our N, which is equivalent to, what do we have? Our N, the second division was 3, y1, which is equal to 2. Then we have over our M plus N is 2 plus 3, like that. So this gives us 2 times 3, that's 6, plus 2 times 3, that's still 6, over, we have our 5, like that. So this gives us our 12 over 5. So this is our QY. So we can say that, therefore, coordinates of Q is going to be equal to, we have our 1 over 5, comma our 12 over our 5, like that. So these are the coordinates of Q. So that's how we solve that one. If you are finding this video very helpful, kindly like and subscribe. So let's look at the next question. This one says, find the value of lambda for which lambda times the identity minus the A is a singular matrix. A singular matrix is a matrix whose determinant is 0. So we have first required where I is an identity matrix. So given that A is equal to that, so we are going to replace. So identity of a matrix is 1 0 0, then the next one will be in the middle, the last one will be at the end. So this is the identity of a matrix. So we have lambda times the identity, which will be 1 0 0 0 1 0 0 0 1, minus what is your A? Your A value is equivalent to, we have our 1 0 2 like that, then we have our 0 negative 1 and negative 2 like that. So we have our 2 negative 2, then we have our 0 like that. So this is what we have. From here, what we are going to do is, let's multiply. This multiplies everything. So this matrix becomes the lambda times 0 is 0 0. So we are going to have 0 wherever you see lambda times this, that's the only change. So wherever you see 0, it's 0 times the lambda like that. So after we do that, we are going to subtract minus our A, which is 1 0 2 0 negative 1 2 2 negative 2 0, if I'm not mistaken. Let's see. Okay, so this is the way it is. Then we subtract. So the way they are, when you're subtracting, you just subtract the same ones with the same one. So this is how we are going to subtract them. So the same colors, we have the yellows, we have the lambda minus 1, then we have 0 minus 0 is 0, then we have 0 minus 2, which is 0 minus 2, so it would be negative 2. Then the other one here, which will be 0 minus 0 is 0. So as you can see, lambda minus this. So now here you need to be careful, it's lambda minus negative 1 like that. Then we have 0 minus negative 2. So we have negative 2. 0 minus negative 2, or 0 minus 2 gives us negative 2 like that. Then we have our 0 minus negative 2. It will be negative by negative, then 2. Lambda minus 0, so it will just be lambda here. So we are going to have something like this, lambda minus 1, then we have 0 negative 2, we have a 0, then we have lambda, negative by negative is positive 1, then negative by negative is positive 2, then we have our negative 2, we have our negative 2. Okay, let's see. What do we have at the end? Minus 2. Oh, okay. So it's having a negative here, which I did not put here. So we have negative, it will be positive. So we say positive 2. Negative by negative is positive, so like that. Then lambda minus 0, it will be just lambda. So we have, this is what we have. Then from there, we are going to say our lambda minus 1, we have 0, we have negative 2, we have 2, lambda plus 1, we have negative 2, we have not negative 2 there, we have 0, then down here we have negative 2, we have 2, we have the lambda like that. Now after you have done this, just know now that the singular matrix, since it's singular, that means to say the determinant of it, which is our lambda minus 1, 0, negative 2, we have 0, lambda plus 1, we have 2, we have negative 2, we have positive 2, we have the lambda. So this should be equal to 0, like that. Now just find the determinant. How do we find the determinant? So finding the determinant is First thing is we exclude this one, we create some form of a triangle like that, then whichever are not yellow, those are the ones that we are going to write, but write the one on top. So we have positive lambda minus 1 times whatever is remaining, which will be our lambda. So we form mini determinants. We have the lambda plus 1, then we have our 2, we have our 2 like that, then we have our which other one do we have? The remaining ones, we have the lambda like that. Then move on to your next one. So the next one is we are going to have something like this. You go to the middle part, you cross them out like that, then whatever is remaining is what you write. So it will be, so it's positive. The first one will be positive, then the next one will be negative, then here we have 0 on top. So whatever we write, it's 0. So it will, we are going to have 0, 2, negative 2, and the lambda like that. Then last but not the least, we have let's reduce this a bit. So last but not the least, we have something like, we have crossing out this, we are going to have our negative 2. We write what's remaining, 0, lambda plus 1, negative 2, positive 2 like that. So now we are going to find determinants. So we have lambda minus 1. So how do we find determinants? We multiply this and this, we subtract this. So this is the same as having lambda outside open brackets, lambda plus 1. Then we have minus 2 times 2 is 4. So minus 2 times 2 is 4, like that. So this is what we are doing. This 0, we don't even need to do anything there. Whatever we are going to have, as long as outside it's 0, it will be 0. Then where is this negative 2 coming from? Okay, it's okay. So the negative 2 is this value, but the determinant formula goes like positive, negative, positive. So here there was a positive, but positive by negative is negative. So that's why we write our negative 2 like that. Then in the brackets we are going to have 0 by 2 is 0, minus, we have this 2, negative 2 times, we have our lambda plus 1, like that. So this is what we have. So we have lambda minus 1, open brackets. In the brackets we have lambda by lambda, it is lambda squared. Lambda by 1, it will be plus lambda minus the 4, like that. Then we have negative 2 times, we have 0. Then we have a negative, like that. So negative by negative is positive. So we have positive 2, lambda plus 1, like that. So what we are going to do from here is multiply. So this lambda multiplies everything that is in here, up to here. So we have this lambda, so lambda multiplied by lambda squared plus the lambda minus 4. Then negative 1 also multiplies everything. So we have lambda squared plus lambda minus 4. Then we have minus our 2. Open bracket, 0 plus 2 is still 2. So we have our 2 by the lambda plus 1, like that. Why have I? Okay. So this is okay. So we have our lambda by lambda is lambda to the third. Lambda by this is lambda squared. Lambda by 4, it will be negative 4 lambda. Lambda by this will be negative lambda squared. This by this. So this by this gives us a negative lambda. Then lambda by negative 4, it will be positive, or negative 1 by negative 1 will be positive 4, like that. Then we have this times this, it will be negative 4, like that, 2 times this is negative 4, then we have lambda plus 1. So we are just going to have lambda cubed plus the lambda squared. Okay, as you can see here, this is having the same power as this, so we forget about this. So we are going to say minus 4 lambda like that. Then we have our minus lambda plus our 4. Negative 4 by lambda, it will be negative 4 lambda like that. Negative 4 by 1 is negative 4. So as you can see, positive 4 minus 4 will give us 0. So we have our lambda to the third minus negative 4 minus, this is the same as 1, minus 4 will be negative 4 minus 1 is negative 5 lambda, minus 4 is negative 9 lambda. Negative 4 plus positive 4 minus 4 is 0. So this will be equal to 0 like that. So factorizing, we are going to have lambda is common, open brackets, we have lambda squared minus 9 should be equal to 0. So that means lambda is equal to 0, or lambda squared minus 9 is equal to 0. So we are going to have lambda should be equal to, lambda squared should be equal to, this 9 goes this side, it will be 9 like that. So lambda, or we find the square root, it will be lambda should be equal to plus or minus 3 like that. So those are our values. Lambda is equal to 0 and lambda is equal to plus or minus 3. Our C says, show that the sum of integers from 1 to n is 1/2 n open brackets n plus 1 like this. So you can use the mathematical induction formula, or you can use the deriving of the formula, which is much easier. So here what we are going to do is that we are going to, so from integers from 1 to n, so that means we have 1 plus 2 plus 3 plus, so it's the sum. We can go on plus 4, but our limit is to some integer n like that. Now if you look at the pattern of this, if n is the last number, it means to say the next number will be your n minus 1, then we have plus the n. Now why do I say this? This is simply because if the numbers are following each other, like 1 plus 2 plus 3 plus 4, that means to say whatever n will be, if n is 100, then this number should be 99. So that's why 100, if n is 100, 100 minus 1 is 99. So we are going to say n minus 1. So we are saying that the sum will be equal to 1 plus 2 plus 3 plus 4 plus that. Then what we are going, so this is how you show. It's not just about finding the answer like this, no. So after that, you are going to write these backwards. So backwards, we are going to have our Sn should be equal to, we have our n plus our n minus 1, then we have our plus dots. If we want, we can say n minus 2, n minus 2, n minus 3, but dots. We are going to have plus our 4 plus our 3 plus our 2 plus our 1. Then what you are going to do is that you are going to add. So adding the 2, we have our Sn should be equal to, we have our 1 plus 2 plus 3 plus dots. We have our n minus 1, then we have our plus n like that. Then we have our backwards is Sn is equal to n plus n minus 1 plus our n minus 2. Then we have plus dots. We have our 3 plus 2 plus 1. So what we are going to do is that we are adding them. So this is how it looks. Sn plus Sn is 2Sn. Now look at the behavior. If you add, we are adding alike terms. So this is more like we add this. It is going to give us 1 plus our n. Plus, if you look again, if we were to add this and this 2, this is going to give us, so if we add this and this 2, we are going to have something like our 2 plus our n minus 1, like that. Even this one, if we were to add it, we are just looking at the behavior. If we were to add this one, it will be plus our 3 plus our n minus 2, plus it's continuing like that. But let's see the behavior. So it's Sn should be equal to, we have 1 plus n, just add the terms that are being added. We have plus our 2, we have n minus 1. If we open the brackets, it's 1 won't change anything. Then we have plus our 3 plus our n minus our 2 plus dots, like that. So we have our 2Sn should be equal to 1 plus our n, like that. Then we have plus our 2, in fact not plus our 2, so it will be this n, so we have our n, 2 minus 1 is positive 1. Even here we have plus our n, 3 minus 2 is 1, so we have our positive 1. So plus dots. So we can conclude that 1 plus n is repeating. So if 1 plus n is repeating, that simply means to say we are going to have our 2Sn is equal to, so therefore 2Sn is equal to 1 plus our n times, how many times is it repeated? N times. So depending on the number of terms, it will be repeated n times. So we can put n times. So conclusion, n, 1 plus n is repeated n times. So this is what we have. So we have 2Sn should be equal to our 1 plus our n times our n. So not say n times. So this is what we have. Now we can put the n in front. We have n. We can begin with our n plus 1. Still the same. We have Sn like that. Then just divide by 2. We have Sn is equal to, this is the same as 1 over 2 n. Whether you write like this or you write 1 over 2 n plus 1, it is still the same. So this is what they wanted us to show. So we can say hence shown, like that. So that's the key to this question. Let's move on to our next question. So if we have our log of our x minus 4 plus our log of our x minus 1 should be equal to positive 1. So solving this one, the log is common, so it's more like you're factorizing them. So you say log, open brackets. When you're adding logs, it means you multiply what is inside. So x minus 4, when you're subtracting, you divide. So x minus 1 should be equal to, we have our positive 1, like that. So this gives us, so if the base is not showing, it means it's base 10. So this 10 likewise will go down there. So it will be our x minus 4, our x minus 1 is equal to 10 to the power of 1, like that. So this gives us, so how we multiply, let this multiply everything. So we have our x, open brackets, x minus 1. Then this negative 4 multiplies everything. We have minus 4. Then we have our x minus 1 should be equal to 0. So we have x by x is x squared. This by this, it will be negative x. Negative 4 by x, it will be negative 4x. Negative by negative, it will be positive 4, like that. Then this should be equal to 0. Oh, sorry, not 0, but there's 10 here. 10 to the power 1. So we have a 10 like that. So doing that, we are going to have our x squared, negative x minus 4x, it will be equal to a negative 5x. We have plus 4. This 10 comes this side, it will be minus 10 is equal to 0. So we have x squared minus our 5x minus 6 should be equal to 0. Then our factors. What are our factors? So knowing that we have the product which is equal to AC. In this case, our A is this, B, C. AC which will be equal to 1 times negative 6 is equal to negative 6. Our sum which is equal to B, so our sum is equal to negative 5. Then factors, our factors are equal to, we have two numbers which when we multiply them they give us negative 6. We add them, they give us negative 5 are negative 6 itself and positive 1. We multiply, they give us that. We add, they give us negative 5. So replacing, we are going to have our x squared minus, we have our 6x like that. Then we have our plus x. Then here we have minus 6 should be equal to 0 like that. So we are going to have something like this. We have our x is common, just in pairs. X is common there, so we have our x minus 6 plus 1. Then what we are remaining with here is 1 is the one that is common, so we have our x minus 6 should be equal to 0. Picking the brackets, we have our x minus 6, we have our x plus 1 should be equal to 0. So either x minus 6 is equal to 0 or our x plus 1 is equal to 0. So that our x is equal to 6 or our x is equal to positive 1. Now look at the equation. Will any of the two work? Will they work? So if you get these equations, one thing that you're not supposed to get is the log of 0 is undefined. So you are not supposed to get 0 here. The log of a negative number, even negative 1, is undefined. It cannot be evaluated. Therefore, you pick the one that is working. So like for example, if I was to put not positive 1, but if it goes the other side, it's negative 1. If I was to put negative 1 here, it will be negative 1 minus 1, that will be negative 5. So it will be the log of, open brackets, negative 1 minus 4, which will be equal to the log of negative 5, which is undefined. Now it doesn't mean that whenever you have a negative it shall be discarded. No, we can have, let's say we have the log of negative 1 but the number inside is plus 4. This can be evaluated, log of positive 3. But if it's giving you a negative, it means to say x is equal to negative 1 is discarded. But if you try your 6, it will work, because 6 minus 4 is 2, 6 minus 1 is 5. So as long as it's a positive value, it will work. So we can be able to say that x is equal to 6 is correct. Okay, so is the one that we are considering. You can even prove it. Log of 6 minus 4, then we have plus the log of, we have our 6 minus 1 should be equal to 1. Now remember, we have the log of 6 minus 4 is 2, plus the log of 6 minus 1 is 5, should be equal to 1 like that. Pick one log, multiply the power, so we have 2 times 5 should be equal to 1. So I'm just showing you how to prove this. 10 goes there. We are going to have our 2 times 5 is 10. So we have our 10 is equal to, this goes there, it will be 10 to the power 1, which is true. So that is how you can just prove if you want to verify. Let's move on to our next question. So the next one is in the expansion of 1 plus ax to the power of n, the first three terms in ascending powers of x are 1 minus 5 over 2x plus 75 over 8x to the power 2. Find the values of n and a and states the range of x for which the expansion is valid. So we have this, our 1 plus our ax to the power of n. We are required to find the values of a and n. So provided that they have given us the three terms. So looking at this, we use the way we expand binomial expansion. So we have 1 plus x to the power of n. So this is equal to, so when you are expanding such an expansion, you say this is equal to 1 plus, you can even memorize if you want. Then the next one will be nx, so this n by this, then we have plus. The third one will be n open brackets n minus 1, like that. Then you have your x will be squared over the 2 factorial. That means to say the next one, if they were 4, you say n open brackets n minus 1, n minus 2, then you have your x to the power 3. X to the power 3 over 3 factorial. The next one like that, but we just need 3 terms. Now using this, now we are going to let our x be equal to, what do we have? We have our ax. Now our x will be equal to ax like that. Then our n, just n is equal to the n. So we are comparing. So we are just going to now substitute. Where we see x, we put ax. So we have 1 plus n, where there is x, we say ax. Then we have plus our n minus 1. Then we have, where there is x, we put ax like that. So we square this over our 2 like that, plus dots, dots, dots. So this is going to give us 1 plus n ax plus, we have our n minus 1. Then we have a squared. So this squared can be distributed. So we have x squared like that over our 2 plus like that. So this is basically what we have, the expansion of the 3 terms. So we just need 3 terms since they have given us the 3 terms. And those 3 terms are 1, what have they said? 1 plus 1 minus, in fact 1 minus 5 over 2 x. Then we have plus our 75 over 8x to the squared, if I'm not mistaken. So this is what we have. Then all you have to do is now compare. So from your comparison, you can be able to see that this and this are the same. So that means to say even this one has to be the same with this one. So we are going to say our n ax should be equal to negative 5 over our 2x like that. So we cancel the x on both sides so that we have our na should be equal to negative 5 over our 2. Also comparing this other one will be equal to 2 factorial, in fact 2 factorial, but 2 factorial is still 2. So we have this one, we are going to compare it. So let's just take this the other side. So we are going to have something like this. Our n minus 1 by our a squared x squared over our 2 should be equal to, we have our 75 over 8x squared. So the x squared and the x squared are there on both sides, so we cancel. Cancelling, we are going to have this and this. So we have our n open brackets n minus 1 a squared over 2 should be equal to 75 over 8. Now knowing that your n is showing 2 times, you make a the subject of a formula so that you can just replace it once. So for this other one, you are going to say over n Now dividing n means it will come here. That's the meaning of division. So it will come down here. Now it's finding itself a 2, so they will be connected like that. Don't bother yourself. Just dividing it, it will join the one that is at the bottom. So we have our a should be equal to -5 over our 2n. So then you are going to replace where there is a, you are going to put this value. So where there is a, you are going to put this value. So putting this value, so we are going to have our n minus 1 over 2. Where there is a, we are going to have our -5 over our 2n. So we have squared like that, should be equal to, we have 75 over 8 like that. So we have our n minus 1. -5 squared gives us a 25 over 2 squared is 4, n squared over, we have our 2 there. So the 2 is here, 2 squared is 4, n squared like that should be equal to 75 over 8. So this gives us a value that will be equivalent to, we have n times n, it will be n squared, n times -1, it will be minus n over 2, then we have times 25 over, we have our 4n squared like that. Then what we are going to have is our 2 times, so this should be equal to 75 over 8. When we do that, it's going to give us, so what we are going to do is that 25, so this 25 multiplies everything, don't make a mistake. So 25 by this, it will be 25 n squared. 25 by this, it will be minus 25 n over 4 times 2 is 8, n squared should be equal to, we have our 75 over our 8 like that. Then you can distribute this by saying this is the same as our 25 n squared, 25 n squared. Okay, let's just cross multiply. So we have our cross multiplication there. So this gives us our 8 times, this 8 multiplies everything. So we have our 8 times 25 n squared minus 25 n should be equal to, we have our 75 times our 8n squared like that. So now remember this is 8, so we can divide our 8 on both sides so that we can simplify our equation, so that we have 25n squared minus 25n, then we have should be equal to, we have our 75 times n squared, so it will be 75n squared. So all of them have got n, so you can divide n throughout, or you can divide n throughout so that you have n divided by n divided by n, so that this becomes 25 n minus 25 should be equal to 75 n. So what we are going to have is this goes the other side, so we have -25 alone should be equal to 75 minus 75n minus 25n. This gives us -25 should be equal to positive 50. 75 minus 25 is 50. We divide by 50, we divide by 50. So this gives us our n value is equal to, so 25 can enter into 25 one time, 25 can enter into 50 two times, so we have -1 over our 2 like that. So that is what we are going to have. Our n is equal to -1 over 2. If n is equal to -1 over 2, remember the one that we made the subject of a formula. It is where's the one we made the subject of a formula? We said a is equal to this value, so we are going to take this value to find our a. So finding our a, it will be equal to we have our a should be equal to negative 5 over 2. What is our a? Our n is equivalent to negative 1 over 2. So 2 times negative 1 over 2, this and this cancels. We are going to remain with a negative 1. So a is equal to negative 5 over negative 1, which will be a is equal to positive 5, like that. So our expansion in this case, which was what was our expected expansion? So we have our 1 plus, where there is a, we put 5x to the power of negative 1 over 2. So using this, we are going to answer the last part of the question to find the validity of the expansion. So you just get this, whichever is connected to x, you say 5x, the absolute value of 5x should be less than 1. Then what you're just going to do is that when you remove these modulus bars, it will be 5x less than 1, even this side less than less than our negative 1, like that. So negative and positive, immediately you remove the absolute value symbol. So the validity is from this range. So you just divide the 5 throughout. So the validity is from the range of 1 over 5 and negative 1 over 5. So just in between these two values, that's when the expansion is valid. Let's move on to our next question. So we have the find the radius of the circle with the center. This, if the line x plus 3y is equal to 9 is a tangent. So if we have the circle, if we have a circle like that, then we have a tangent. Remember, a tangent is a straight line that cuts the circle like that. So this is the tangent, like this. Then we have the center. So the center and the tangent will be perpendicular. Now remember, coordinate geometry has made it very easy to find the distance of a line that is perpendicular. And this line is at the center from negative 2,5. So coordinate geometry has made it very easy. So this is where you apply your knowledge of coordinate geometry to find the line of a line that is perpendicular to another line. So finding the distance of this line, since it's perpendicular, so we have the tangent, the radius is perpendicular, like that. So you are going to use that formula that we have. The distance of a perpendicular line is given by the absolute value of your line itself, the absolute value of the line itself over the square of the coefficient of a and b. So in this case, it passes at negative 2 and negative 5. Then the straight line, you must make sure that it's x plus your 3y. Then this 9 comes here, it will be negative 9 is equal to 0. Make sure it's like this. So this is where you apply that equation, where you apply the equation of the perpendicular line. So you have this. Then it passes at the point, or rather this is beginning at negative 2,5. So this distance now is the radius. So we are going to say the radius will be equal to, what's our a? So the coefficient of a here is 1. So we say 1. Our x value is, so we have x, we have y. So x value is negative 2. Then we have plus. Our b is 3. So we say 3. Then we have, what is our y? Our y is 5. So we say 5. Then we say plus. What's our c? Our c is negative 9. So we have negative 9. Absolute value over the root of, what's our a squared? So our a squared is 1 squared. So we have 1 squared plus our b is 3. So we have 3 squared. So r is equal to 1 by negative 2. It will be negative 2. 3 by 5 is 15. Then we have negative by positive. It will be negative 9, like that. over the root of, we have 1 squared is 1 plus 3 squared is 9, like that. So our error should be equal to, we have our value of -2 by, so we have 11 here. So here if you look at it, -2 by, -2 minus 9 is -11 plus 15. That will be a +4. So the absolute of 4 over the root of 10. That means if in the bracket it was -5, absolute of -4 is +4. So that's why the absolute value is important. So we have our error should be equal to, the absolute value of 4 is 4 over the root of 10. So lecturers want to complicate things, so they want the equation to be rationalized. So you introduce the root of 10 on both numbers so that you know to say root 10 times root 10. If the root is the same, this and this goes, and you just maintain what is inside. So it will be 4 root of 10 over, we have the 10 like that. 4 divided by 10 is, 2 can enter into 4 2 times, 2 can enter into 10 5 times. So we have our 2 over our 5, then we have our root of our 10 like that. So this is the radius. Just in case they asked you the equation of the circle, find equation of the circle in standard form. So this is the answer for that part. Just in case, equation of circle in standard form is given in the form x minus h squared. Then we have plus our value, which is our y minus our g squared, like that, should be equal to r squared. So this is the equation of the circle. So it will be x minus, what is our h? H is the coordinate of x for the center, which is -2. So we say -2. So it will be -2 squared plus y minus g is 5. The equation, the coordinate of y at the center should be equal to, our r is our 2 root of 10 over our 5. Then we square this. So we are going to get x, negative by negative is +2, plus y minus 5 should be equal to 2 squared is 4, root of 10 squared. So this squared is distributed throughout. So this is what we have. So we have x plus 2 squared, x plus 2 squared, plus our y minus 5 squared, 5 squared should be equal to 4. Roots and the square will cancel, so we have by 10 over 5 by 5 is 25, like that. So this is what we have, x plus 2 squared plus our y minus 5 squared should be equal to 4 times 10 is, in fact we can reduce here, 5 can enter into 25 5 times, 5 can enter into 2, 10 can enter, 5 can enter into 10 2 times. 4 times 2 is 8 over our 5. So this is the equation of the center, or this is the equation of the circle. Our B, question B, for our B, we have our 0.214 bar. So the bar is just on 14. So what this means is that this number is 0.214. If this is repeating 141414, like that. So this can be written as 0.2, which is not repeating, plus 0. Where there is 2, you put 0, 14, like that. The next term will be, if you are adding, you want to maintain this meaning, it will be plus your 0.0. So up to here you put zeros, so 3 zeros, 14, like that. When you add these, you are going to come back to this, you add again, so all these numbers will now become zeros. 1 1 2 3 4 5 1 4, like that. It continues like that. So now if you have such a question, this one you isolate it, you treat it as separate if it's not repeating. Then you are going to find the sum to infinity for these that are repeating. So you are going to say the sum to infinity is given by a over 1 minus r, like that. So our sum to infinity is given by a. So from here, so this will be your first term, this will be your a. Then r, you are going to find it. So let's first find let's identify a is equal to 0.014. r is equal to, we have our term number 2 over term number 1. So r is equal to, what is our term number 2? Term number 2 is this. So we are going to take all of this 0.00430, like that, divided by term number 1, which is 0.014, which is this one, 0.014. So what we are going to do now is we have 1, 2, 3, 4, 5. To get rid of the zeros, we need to move 1, 2, 3, 4, 5. So we need to multiply by 10 to the power of 5. Even here, 10 to the power of 5. So that r becomes 1, 2, 3, 4, 5. That means to say the 5 zeros have been used up, over. Then here it will be 5 zeros, it will be 1, 2, 3, 4, 5. So we have 1,400, like that. So 14 can enter into this by 1 there. Then we have the zeros there. So we have r is equal to 1 over 100, which will give us 1 divided by 100 is 0 point. We add the 0. 10 divided by 100 is 0. We add the 0. So it's 1, like that. So if it is like this, we are going to say sum to infinity is equal to 1 minus r. So what is our a value? A is 0.014 over 1 minus r is 0.01. So this gives us our 1.00 minus, so this one is 1.00 minus our 0.01. This gives us our value, which will be equal to, we get 1 there, it will be 10 here, we get another one, so here it will be 9, 1, 10 minus 1, that will be 9. This 9 minus 0 will be 9.0. So we are going to get our 1 minus, so we have 0.014 over 1 minus 0.01, we are getting 0.99. From here we have 3 numbers after the decimal point, so we multiply by 1000. 1000 is the same as 10 to the power 3. So if I say 10 to the power 3, it's 1000, because the power will indicate the number of zeros. So I'll multiply 10 to the power 3, but if you want, you can write 1000. So it will be 1, 2, 3. So on top it will be 14 over, this will be 1, 2, 3, so that the 0 becomes there. So we have 990. Now 2 can enter into both numbers. So 14 divided by 2 is 7. Okay, let me be careful. Let me not do that, because of that other number 0.2. It has got a 10. Then after you reach this stage, so this is the sum to infinity. It is equal to that. So therefore, we are going to say, to find the value of 0.214 bar, it should be equal to the 0.2 that you left plus the sum to infinity that you have found. So we have our 0.2 plus sum to infinity is found to be 4 over 990. Then this one is 0.2 is the same as a 2 over 10. If you divide 2 divided by 10 is 0. You add a 0, 20 divided by this is 0.2. So just that number divided by 10. So this gives us a value of plus our 14 over 990. So the common denominator, since this is 10 can enter into 990, so we say 990 like that. Then we say 990 divided by 10, it's 99. 99 times the 2, it will be 198. So we say 198. 990 divided by 990, it's 1 times 14, that would be 14. So we add 198 plus 14 will give us a 2, 0. Okay, let's just add properly. 198 plus 14, 2, remainder 1. We have 10 plus 1, that would be 1, remainder 1. So we have 212, not 20. So we have 212 over 990. So 2 can enter into both numbers. We have here it's 1. 2 divided by 1 is 0. 12 divided by 2 is 6. Here it will be 9 divided by 2 is 4, remainder 1. 19 divided by 2 is 9, remainder 1. 10 divided by 2 is 5. So we have our 106 over 495, like this. So this is our value of 0.214 using the geometric method. Let's move on to our next question. So let's say we have this one: use mathematical induction to prove that the statement is true for all positive integers n, given that n 4 to the power n minus 1 is divisible by 3. So what are we going to do? So we are going to say 4 to the power n minus 1 is divisible by 3. We are trying to prove. So we begin with the basic step. So basic step, we are going to let our n be equal to 1, so that we see the value that it will give us. So it will be 4 to the power 1 minus 1, which will be equal to 4 minus 1, which will be 3, like that. From there, we are going to come up with our inductive hypothesis. So the inductive hypothesis will be where we are going to assume, so here, this 3, it has given us 3, so we can say it is true. It's true because 3 is divisible by 3 itself, so you can divide 3. Then the inductive step, you are going to assume that it is true for n is equal to k. This gives us our n is equal to k. N is equal to k, so we have 4n minus 1. Now, if a number is divisible, I explained in another video, if you have, let's say 8 is equal to 2, like this. If you have 8 is equal to 2 times 4. So this means to say 8 is the same as 2 times 4. So whenever you have any number, it could be like this. Now where there is 4, you can say x in such a way that when you divide this, it will be able to give you x is equal to 4. So in other words, 8 is the same as 2 times the 4 there. So if the number that can be divided is 2, so it is the same like that. So this is the same. If 4 is divisible by 3, it means to say we are going to say this will be 3, because we know it's divisible, times the x. X is representing this number. This 3 is the one that is showing there. Then we are going from here, we are going to go for the inductive step. So remember, it's the basic hypothesis where you assume, then inductive step. So now, from there, what we are going to have is, we are going to say, assuming, or we are not assuming. Let's prove that it is true for n is equal to k plus 1. Now, how you are going to introduce k plus 1 is, you are not going to substitute 3, not 3k, not 3k, not 3k, not 3k, not 3n, but 3k. So you are going to substitute, or you are going to multiply. So where you are going to take your 4k plus minus your 1 should be equal to, you have your 3x like that. So what you're going to do is that you're going to multiply. But before that, let's take the 1. Always take the 1 the other side. But if you take it later, it will still work. So we have 4k should be equal to 3x plus 1. From here, always the one with the power k is the one that you multiply. So you're going to have 4. Multiplying everything. So that 4 times this, it will be 4 times the 4 to the power k. Should be equal to, we have our 4 times 3, it will be 4 times, dots can mean times, 3x, we have plus, 4 times 1, it will be 4 like that. Now, rules of indices, pick one base, so it will be 4, adds the power, so it will be k plus 1. Should be equal to, we have, if you look here, we have our 4.3x. Now we want the 3 to be outside, like this. So this is what we are going to do. So this 4 is the same as a 3 plus a 1. Then take this 3 the other side. So it will be 4k plus 1 minus 1 should be equal to 4.3x plus our 3. Now remember, the reason why you are doing this, you have to show these statements are very important. These assume that it is true for n is equal to k. So this is how you represent your work. So we are going to have this 3 and this 3 are common. So we have 4k plus 1 minus 1 should be equal to 3 is common, open brackets, we have our 4 that is remaining, and our x, then plus 3 divided by 3 is 1, like that. So as you can see, as long as the 3 is outside, it means to say it is a factor, or rather it is divisible by 3. So you can say, therefore, it is divisible by proof of mathematical induction. Proof of mathematical induction. So it is true for by proof of mathematical induction. Let's move on to our next question. We have graph f of x is equal to the log of 1 over 2 x by reflecting the g of x is equal to 1 over 2 to the power of x across on y is equal to x. So we are going to graph. Now remember, I've already graphed these. I've already graphed these. So if you look at the graph of an exponential, this one passes at 1, positive 1. Now if you have a number that is less than 1, such as 1 over 2, it means to say your fraction will be coming from, it is a decreasing function, meaning it's coming from here going like that. So you have, this is your, so this is how you graph this. So it will pass at 1 like that. Then let's now draw the line of y is equal to x. So the line of y is equal to x passes like this, passes at this point. But you can show. So this line, okay. So this line passes at this point. Yeah, so this line passes at this point. As you can see, this line passes at this point. Let's differentiate the color. Now this line, you can even draw the table of values for this line. We have our x, we have our y. So that means to say we have, when we have 0, we have 0. So when x is equal to 0, we replace here, it will be y is equal to 0. When x is equal to 1, y is equal to 1. When x is equal to 2, y is equal to 2. So we are going to get our 2. So 1, 1. So the two graphs, always, if you have y is equal to 1, they will meet at this point where the value here is equal to positive 1. But here it is equal to positive a half, like that. So this is the meeting point. So where the three graphs meet, that is where also the graph of this will also be able to meet. Now this other equation, if you are drawing by reflection, it passes like this. So they will meet at this point and go like that. So this is how the equations pass. So this one is our y should be equal to, we have our x. This one is our y is equal to, is it f of x? This is f of x is equal to the log of half of our x, like that. Okay, so we have, power x, like that. How is it first? Half of x. So reflecting this, as you can see, this equation has been reflected in the sense that for this one, which is our g of x is equal to half to the power of x. This equation has got a coordinate here. This is at this point x is equal to 0. So we have 0, positive 1. Reflecting this same coordinate, it means to say why they are interchanging, we have 1, 0. So that's how come here we have that's how come here where it's passing the x-axis. Okay, sorry about that one. So here we have a 0, 1. Reflecting this is 1, 0. So this means to say this point is a 1, 0. So these are the points. So now to just guarantee you the full marks, what you're going to do is, you have labeled that, you're just going to attach the domain. So the domain of your g of x, so the g of x, remember, is this exponential. As you can see, domain shows you the x coordinates. So it is it is going this side throughout. So it's increasing to positive infinity. At the same time, it is also going this other side. So it is having all the values of x. So the domain for this domain are all x values. So the domain will be equal to negative infinity to positive infinity. Then the range of g of x will be equal to, as you can see, it's not crossing this. So that's the smallest value. So it will be 0 not included. It's not touching, positive infinity, it's going up. Likewise, we are going to have the domain also. The domain of the other one, which is our f of x, will be equal to, so as you can see, this one, the domain are x values. It's not crossing this boundary. It's not crossing the boundary. Therefore, the domain will be from 0 to positive infinity. It's continuing this other side, but it's not more like crossing this boundary. So that's the domain. Then the range of f of x will be equal to, we are going to have, as you can see, it's going up like that, and even down here it is still going down. The end is not known. So the range for this one is a negative infinity to positive infinity, like that. Let's move on to our next question. So in short, before we move to our next question, just look at this. so they will always meet per, then this is passing here. So just note to say I need to pass at least where we'll meet, then we'll meet like that. So that's the connection. So even if you don't know how to graph this, as long as there is half for logs, if there is half, if you have the log of half, it looks like this. So it's a decreasing function. For exponentials, if you have half like this, it moves from this side going the other side like that. So then what is the next one that we are going to look at? So this one is the main meat, and I think it's going to take a bit of time. It's going to take a bit of time. So what we can do is, let's solve this at the end. Let's solve this one at the end. Let's go to 4 so that one will be at the end. So question 4. So our fourth one, we are going to come back to that. Our fourth one says we have 1 minus 2 over 3 plus our 4 over 9 minus our 8 over 27 plus our ... So what we are going to do is, we are required to do the sigma notation. Immediately you see division, your idea should be it's a GP. So you are going to say testing if it's a GP. You are going to find the common ratio is term number 2 over term number 1. Common ratio is also term number 3 over term number 2. So R should be equal to term number 2 is 2 over 3. So we are going to have negative 2 over 3 over our first term, which is 1. So our R will be negative 2 over 3. If it's going to give you the same answer for R is equal to term number 3, which is 4 over 9. 4 over 9 divided by, we have term number 2, which is our negative 2 over 3. So we have our R should be equal to 4 over 9. Negative will turn in, division will turn in 2 times. The 3 will go up over negative 2. So this and this, we are going to have 3 there. We have our 1 here. So we have R is equal to 4 times our 1. In fact, the 2 can enter there. We have negative, we have 1, negative 2 can enter into 4, negative 2 times. So we have negative by 1, it will be negative 2 over the 3. So it is the same. So that means to say, we are going to say it is a GP. Therefore, knowing that the term of a GP is given by our ARN minus 1, which will be, if you want, you can say term like this. So the term, any term of a GP, first term is 1, then our R is negative 2 over 3 to the power of n minus 1 like that, which is unknown. Now, the end is unknown, ... meaning it's going to infinity. So we are going to say, so that means to say we are going to say, therefore, using the sigma notation, it means summation from our, so this equation is 1 by negative 2 over 3 to the power of n minus 1. So the only way we can get a 1 is, we know that any number to the power of 0 is 1. So we need to create a 1. So that means if we have 1, 1 minus 1 is 0. So that means to say our n should begin from 1, but our greatest value should be some positive infinite. If we put 1 minus 1, it's 0. And negative 2 over 3, if it's in bracket to the power 0, is positive. It will be 0, like, it will be 1, sorry. It will be positive 1 like that. So this is our answer for that one. Then for this one, so for this one, especially if it's 5 marks, you are going to test if it is a GP. That means divide this divided by this. So term number 2, R is equal to term number 2 over term number 1, which will be, term number 2 is 2 to the power 4 over 1 to the power 4. 2 to the power 4 is 16 over 1, which will just be 16. R can also be equal to term number 3 over term number 2. term number 3 is 3 to the power 4 over our 2 to the power 4, which is equivalent to 3 to the power 4 is equal to 81, if I'm not mistaken, because 3 times 3 is 9, times 3 is 27, times 3 is 81. So we have 81 over 2 to the power 4 is 16. So R is different. That means it is not a GP. Test if it is an AP. An AP, that means the difference should be the same, which will be the common difference should be the same. That is term number 2 minus term number 1 should be the same as term number 3 minus term number 2. Especially if it's 5 marks, this is how you represent your work. So D is equal to term number 2 is 2 to the power 4 minus 1 to the power 4. Then this other one will be T3 will be 3 to the power 4 minus 2 to the power 4, which will give us 81 minus 16, and our 16 minus 1, which will be 15. This one will be 81 minus 16. This will be 11 minus 6 will be 5, 65. So D is different. So if D is different, that means to say it is not an AP. Therefore, by observation, the integers are increasing. So this is 1, 2, 3 until n plus 1 to the power 4. So we are going to say the integers are increasing from 1 until n plus 1 to power 4. So we can now be able to say, so this will be the summation as n plus 1, the final one, n is equal to 1 for I to the power 4. So that it begins at 1 to the power 4 plus the next one would be 1 to the power, or the next one will be 2 to the power 4. It will increase until n plus 1 to the power of 4. So that is how you answer that one. Then the next one is, provided with this question, the number of grams of a certain radioactive substance present after T hours is given by the equation. So we have our Q should be equal to Q0 e to the power of negative 0.45 T, like that. So how are we going to solve this one? So how we are going to solve this one is by simply substituting. So Q0 is the original. So how long will it take to move from this amount of grams to this? So we are this, where this Q is the remaining. So this is the remaining. So we have 1050 should be equal to 2500. Then we have e to the power negative 0.45 t, like that. We divide by 2500. This gives us, this divided by this is 1 over 2, should be equal to e to the power of negative 0.45, because this divided by this is just 1 over the 2. So they like questions where you simplify to 1 over 2 mostly. They have given you that the ln of half is this. So we are going to introduce the ln, the natural log, ln of half, like that, on both sides should be equal to the ln of e. Then we have, so ln is a natural log, so the rules is that the power can drop. So we have the ln of half. We are told that it's negative 0.693, which should be equal to, when that power drops, we have negative 0.45 ln of e. So ln has got the base, which is this, and the log of the same base is equal to 1. So we have the t there. We have negative 0.45t. We have negative 0.693 like that. We divide negative 0.45. We divide negative 0.45 like that. Our t should be equal to 0.693 over 0.45 like that. So we have negatives. This negative and this negative cancels. So our t should be equal to 0.693 over 0.45. Likewise, there are 3 numbers, so we multiply by 1000. Even here 1000, so that we have 1, 2, 3. It will be t should be equal to 693 over 1, 2, 3. So there will be a 0, so we say 450 like that. Then the binomial one. So we have expand this and this in ascending powers of x. So you say 1 plus our 2x to the power of our 4, and we have 1 minus our 2x to the power of 4 in ascending powers of x. So this means that to expand this, we are going to get, so expanding this using the Pascal's triangle. So we can say by Pascal's triangle, power is 4, so we say 1, 1, 1, 2 here. Then 1 plus 2 is 3, 2 plus 1 is 3, 1 outside. This plus this is 4, this plus this is 6, this plus this is 4, 1, 1 like that. So using these, we are going to expand both of them. So we have 1 plus our 2x to the power of 4. So expanding this, we are going to have our 1 by our 2x like that, plus. So just write these. If you have the power 4, you will have 5 terms. So write these, repeat them 5 times. 1, 2x until 5 times. But you have enough space, so you can write 5 times like that. 5 times. Power is 4, so move from 4, 3, 2, 1, 0. From here, move from 0, 0, 1, 2, 3, 4, which will be 1 to the power 4 is 1, 2x to the power 0 is 1, then we have plus, we have 1, 2x plus, we have 1, 2 to the power 2 is 4, x squared like that, we have plus our 1. We can even be ignoring the ones except there, because 1 won't change anything. So we have our next one will be 2 to the power 3 is 8, x to the power of 3. Then we have plus 2 to the power 4 is 16, x to the power of 4, like that. Then get your coefficient. So you are getting your 1, put these values in front. So that's why I was leaving some space. If you want, you can just write it here. We have 1 plus, put the coefficient there. So the first coefficient is 4. So we are going to have 4 by our 2x plus, we are going to have our next one is 6. So we say 6 by our 4x, 4x squared plus our another 4, 8x cubed. Then we have plus another 4. Is it another 4 or a 1? Okay, another 4. How many terms are these? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, it's just 1 4. Then the last one will be 1. So we have 1 by 16 x to the power 4 like that. So we have 1 plus this times this is 8 x plus 6 times 4 is 24 x squared plus we have 4 times 8, it will be 32 x to the power 3. Then we have plus our 16 x to the power of 4 like that. So this is basically what we have. So this is basically what we have as our equation like that. Then for this other one, 1 minus our 2x to the power of 4. So we are required to expand both. So we are going to do the same. So using the Pascals, we have 1 negative 2x plus 1 negative 2x plus 1 negative 2x. Then we have plus 1 negative 2x plus 1 negative 2x plus 1 negative 2x like that. How many terms are these? 1, 2, 3, 4, 5. Too many. Just need 5 terms. So we are moving from 4, 3, 2, 1, 0. 0, 1, 2, 3, 4. So we are going to have our 1 to the power of 4. It's going to give us 1. Then we have our negative 2, that's to the power 0 is just 1. So we have plus 1 won't change anything. So let's stop writing 1 outside. Negative 2 times or to the power 1, it's negative 2. So we say negative 2x. Negative 2 to the power 2, if it's in bracket, it will be positive. So positive 4x squared. Negative 2 to the power 3, it will be negative 8x to the power 3. Negative 2 to the power 4 will be 16x to the power of 4 like that. So the expansion, have we put we haven't put the coefficients. So we can say attaching coefficients. So attaching coefficients, we are going to have something like this. We have 1 minus, then the next coefficient that we had, remember the coefficients, 4, 6, 4, 1. So for the next one, for the first one is 1, then the next one it will be 4 by our 2x, but the negative has been written here. Plus the next coefficient is our 6 by our negative 8x to the power 3. Then we have plus our next coefficient. Have I skipped a number? So this is 4x squared, 4x squared, plus we have another 4. Then we have our negative 8x to the power 3 like that. Then the last one coefficient, it's 1 times the last number, which is our 16x to the power 4. So we have 1 negative by this, it will be negative 8x. The next one will be positive 24 if we multiply this. Then the next one, positive 4 times negative 8, it will be negative 32x to the power 3. So 1 times, this is positive 1. 1 times 16, it will be plus our 16x to the power of 4 like that. So these are our terms. So this is the expansion for that. So we have expanded. Then we are told, hence reduce this to its simplest form. So reducing this to its simplest form, we are going to say our 1 plus 2x to the power of 4 minus 1 minus 2 to the power x to the power of 4. So remember, this one is the expansion. This one is the expansion for 1 minus 2x to the power of 4. Likewise, this other one is the expansion for the one for the positive. So we already have the expansion. So this is the one for 1 plus our 2x. Is it 1 plus 2x? What? 1 plus 2x to the power of 4. So what we are going to do is we are subtracting this. So we are just subtracting the expansions. So this is the same as having what is the expansion of this. So we are just going to get it like this. So it will be equal to our 1 plus our 8x. Okay, so let's just get this. The expansion of this is this, so we get this expansion. So getting this expansion like this. So we have plus 16x to the power 4. Subtracting it with the expansion for this. So we also get this expansion and just subtract. So that is basically what they want for us to just get those 3 marks. So we subtract. So when we do that, we are going to get 1 minus 1 is 0. 8. So we are going to say 8. Negative by this, we are going to have our 8x. Then negative by negative will be positive 8x. 24 minus 24, it is 0. 32 minus negative 32, so we are going to have 32x cubed. X cubed plus, because this negative and this negative are multiplied to become positive, so we say plus our 32x to the third. Then we have 16 minus 16 was 16 minus 16 is 0x to the power 4, like that. Then our 8 plus 8, it is equal to our 16x, like that. 32 plus 32 will be 64x to the power 3. So this is the required answer. Then the final question is saying that using the results in 2, evaluate 1.002 to the power of 4 minus 0.998 to the power 4. So you just need to think critically. So this is the same as having 1 plus 0.12 like this. 0.002, it will give you that power, this. Now if you look at this, how can you have this number? So the key is you want it to look like this. You want it to look like this. So you are going to say, so you can test what number can I subtract, but it has to be 1. Here it has to be 1. But since 1 is greater than this, you will say minus. Now look, 1.00 minus 0.998. Is it 998? This is going to give us, we get a 10 here, we get again, we get, it will be 10 minus 8, it will be 2, 0, 0.0. So what we are going to have is, this number is the same as 1 minus 0.002 to the power of 4, like that. So this gives us a value that will be equal to, so if you look at this one, this is the same number, but we have a 2 attached, so we need to find the value of x. So we are going to say 2x is equal to 0.002. So why are we saying 2x? Because this number is not 2x, so we have to find the value of x. So this is the same as x is equal to 0.00, 2 divided by 2 is 1, 0.001, like that. So this, if that's the case, it means to say this is the same as 1 plus our 2 by 0.001, like this, minus our 1 minus 2 by 0.001, so squared, like that. Now we already know that if we subtract these two, we had a 16x plus 64 plus 64 x to the power of 4 to the power of 3 to the power of 3. So we are going to replace where there is x is equal to this. So we are going to replace, so we have 16 by 0.001 plus 64 by 0.001 to the power of 3. So it will be 16 times, this is the same as writing 1 over, if you have 3 numbers here, it means it's 1000, plus 64 times 1 over, it will still 1000, but the power is 3. Even this one is 3, but it's the whole thing that will be power 3, but in fact it's just the bottom number because it's the one that is 1000 to the power 3, like that. So this gives us 16 over 1000, like that, plus 64, then over, if you have power 3, it means to say these 3 zeros will repeat themselves 3 times. So we will have 1 2 3 1 2 3 1 2 3, so that you have power 3 means 3 zeros repeated, like that. So the common denominator here is 1 billion, like that. So this 1 billion divided by this, it will be this number, this red number in red will be the remaining. So this times 16, it will be 16 million. So 1 2 3 4 5 6. So just write 16 times 1 is 16, then repeat the zeros. This number divided by this number, it is 1 times the 64. So the final answer can be 16 0 0 0 1 2, or not even 1 2, then we are going to have 64. So look at the place values, then over 1 billion. So this is the value. So this is the value. You can even leave it like this. What have they said? Using the results, evaluate. You can even leave it like this. But in any case, we can just finish it. But yeah, it's still okay just leaving it like this. But just in case your lecturer is strict, you can see that the number of values here is 1 2 3 4 5 6 7. Here it's 1 2 3 4 5 6 7 8. Okay, so let's match up like this. How many are these? 1 2 3 4 5 6 7. 1 2 3 4 5 6 7 8. So even here it's 1 2 3 4 5 6 7 8, like that. So if that's the case, that means to say it will just be 0 point, you add a 0, these numbers will now become 9, so it's still 0. You add another 0, this becomes bigger, so it will be 1. Then from here, when everything is replicated, it will just be the same value. You just repeat it as long as you reach there. Okay, so this is what we are going to have as our answer. But even leaving it like this is okay, but depends with your lecture. I think for this other one, I don't want the video to skyrocket to 3 hours, so we are going to solve this equation, this question for matrices separately in a separate video. Make sure you like and give it a thumbs up. See you in the next tutorial.